Welcome to the Kubernetes API presentation. In this session, we will dive deep into the Kubernetes API architecture and learn how to interact with it. Here's the agenda for today's presentation. We will cover the Kubernetes API architecture, how to interact with the API, API groups and versions, and the Kubernetes object model. The Kubernetes API is the core mechanism for interacting with the Kubernetes cluster. It provides several key functionalities: declarative configuration of resources, communication between components, RESTful interface for automation, authentication and authorization mechanisms. The Kubernetes API is structured into several components. API server. This is the main entry point for requests. etcd. This component serves as the persistent storage for the cluster state. Admission controllers. These validate and modify requests. Controllers and operators. These watch for resource changes and reconcile the drift between the actual and the desired state. Understanding these components is crucial for effectively managing and interacting with the Kubernetes cluster. Let's walk through the sequence of events when a user creates a deployment using kubectl. The user creates a deployment with kubectl. The kubectl request is forwarded to the API server. The request is then sent to the admission plugins. Once the request is validated by the admission plugins, the deployment object is saved to the etcd database. The deployment created event is then prompted to the user. The deployment controller watches for new deployment objects. It detects the new deployment created. The deployment controller initiates a replica set creation. The replica set creation is communicated to the API server. Similar to the deployment controller, the replica set controller creates the necessary resources such as pods. This sequence ensures that the desired state specified by the user is achieved and maintained by Kubernetes. You can interact with the Kubernetes API using several methods. First, we have kubectl, the command line interface. This is the most common tool for managing Kubernetes clusters and performing various operations. Next, you can make direct REST API calls. This allows you to interact with the API programmatically using HTTP requests. Another option is to use client libraries. These SDKs are available for various programming languages and provide a more convenient way to interact with the API. You can also use the web UIs such as the Kubernetes dashboards, Lens, and Octant. These graphical interfaces make it easier to visualize and manage your cluster. Finally, you can extend the API with custom controllers and custom resource definitions. This allows you to add new resource types and automate complex workflows. Here's an example of an API call using curl. This command retrieves information about the nodes in your cluster. The Kubernetes API is organized into groups and versions to manage the various resources within a cluster. First, we have the core group. This includes essential resources such as nodes, pods, namespaces, services, config maps, and secrets. These resources are accessed via the API/v1 endpoint. For example, to access secrets within a namespace, you would use the following path. Next, we have named groups. These groups categorize related functionalities. For instance, the apps groups manage resources like deployment, stateful sets, daemon sets, and replica sets. The path for accessing deployments within a namespace would be the following. Additionally, there are cluster scope resources that are not bound to a namespace. An example for this is the cluster role resource, which is accessed via the path api/rbac.authorization.kubernetes.io/v1/cluster roles. Note that there is no namespace in the path for this resource. Here's an example of a resource definition in YAML format. The API version field specifies the group and version of the resource, while the kind field defines the concrete representation or schema of the resource type. In this case, it's a deployment. The resource type is the name used in the REST path. For example, the path to access deployments within a namespace would be the following. To see all the available API resources in your cluster, you can use the kubectl API resources command. This command lists all the resources, their short names, API versions, whether they are namespaced, and their kind. Every Kubernetes object must have several key fields. The type meta field defines the object's API version and kind. The object meta field contains identifiers such as name, namespace, UID, and resource version. It also includes timestamps for creation and deletion, as well as labels and annotation for organization and categorization. The spec field represents the desired state of the object, while the status field summarizes the current state of the object in the system. Here's a diagram of Kubernetes object model. Here's an example of a Kubernetes object in YAML format. The API version field specifies the API version, and the kind field defines the type of the resource, in this case, a pod. The metadata field contains identifiers such as namespace, name, UID, resource version, creation timestamp, deletion timestamp, labels, and annotations. The spec field represents the desired state of the object, including the containers, their images, ports, and restart policy. The status field summarizes the current state of the object, including the phase, conditions, host IP, pod IP, and start time. Thank you for attending this presentation on Kubernetes API. If you want to learn more, you can watch the video linked here or follow the Killer Quota hands-on lab I have linked here. You can also visit the Kubernetes documentation for more information on the API reference and kubectl.